Good morning. Welcome to Monoxivent's fourth webinar. So it's a series of webinars we're hosting on various topics. We hold these on the last Friday of every month. My name's Ian Frink. I'm one of the owners at Monoxivent, and I'd like to thank everyone for their time. I know everybody's busy, and we certainly appreciate you taking time out of your schedules to sit through our presentation. Just a little bit of housekeeping for everybody. The Monoxivent website, under the Resources tab, has a list of our webinars, and any webinars that are missed can be downloaded through YouTube. We'd also like to encourage people in the lower left corner to text questions to us. We'll read them back, and benefit for all there is just to kind of get some Q&A going and some discussion, so we certainly encourage people to do that. Today's presentation is on corrosion composites. We're going to give an overview on that. That's under our fiberglass products division, and our presenter is Terry Cahill. Terry came to Monoxivent in 2008, and he's our division manager. He oversees underduct and corrosion composites, has 30 years of experience in the fiberglass industry, and is really nationally known. And we're fortunate to have him, and we're going to learn a little bit more about corrosion. When Terry isn't working, he enjoys time with his family. He's an accomplished rower, and he is also a runner. So just to give you a quick sidebar of what corrosion composites is, it's a industrial water, wastewater, underground, HVAC applications. That's where you're going to find corrosion. So this is different than the underduct product we sell. Underduct is more plan and spec, HVAC type duct. Corrosion is very custom in nature. It's lightweight, high strength, non-conductive. You could see these in water treatment plants, chemical plants, a lot of industrial applications where corrosion needs to be taken into consideration. Hoods, ducts, pipes, tanks, scrubbers, these are all typical areas, and Terry's going to talk about all those. And then I'd be remiss if I didn't talk about our great internal support structure. We have two engineers from Iowa State, Brian Phipps, Sam Stelzner as support. Jim Wischusen's a senior product manager. We have two sales managers, Mike Murphy and Daryl Fetter. So we certainly have a great crew, and they can help from the design and the concept through project management and delivery. All of those things, we provide that in-house. So without further ado, I'm going to turn it over to Terry, and he's going to give our presentation. Thank you.
Thank you, Ian. Just to explain the difference between corrosion composites and underduct. Underduct is a Class 1 duct material. It's ICC listed, code compliant for underground heating and ventilating, HVAC. For corrosion composites, the subject area that we're going to talk about today is an older, more established area based, and all of the standards are based on ASTM standards, all the manufacturing. So what is a composite? What is fiberglass? A composite is two or more different materials combined to make a new product that has new superior properties to the individual components. Think of concrete with rebar in it as another composite. A typical fiberglass composite consists of glass strands in a thermoset resin matrix. The glass adds the structural element, much like rebar in concrete does. The resin is a matrix, and the matrix will fill in, and that will dictate the properties like corrosion resistance, temperature limits, toughness, and many other properties. Typical markets served in the corrosion area would be industry, water, wastewater, and in some cases architectural. We would like to put the emphasis on the custom design and fabrication. The custom design and fabrication covers many, many items. However, there are companies that specialize in just pipe and fittings, and there are companies that specialize in storage tanks only. We are definitely in the custom side of it. One of the most important things when you start a project is selecting the best material for the job. And the considerations would be chemical exposure, temperature, structural requirements, expected lifespan, abrasion resistance, cost. Those are the main considerations that you would start with.
Harry, we had a question, and I just wanted to read that. The question is, what are the competitors to Corrosion Composites? Who do you see in this typically? Is it the same competitors that you might see for underduct? Could you just touch on that for us?
The competitors in the corrosion market would vary. As I mentioned, some companies specialize in tanks, others in pipe. Others are strictly in the duct business. And we have competitors all across the country in the corrosion market. We have Daniels on the West Coast. We have Augusta. We have Perry Fiberglass. We have many, many. Okay, I hope that answered the question. Fiberglass laminate composites are lightweight, high strength, non-conductive, corrosion resistant, and Monoxivent can assist with the design, engineering, drawing, manufacturing, inspection, all aspects of a project. We bring together the fiberglass experience and manufacturing expertise. For industrial and wastewater projects, fiberglass is the material of choice for most corrosion applications. We're looking at a large industrial duct. That's a shop fabricated piece being lowered into position. Okay, what kind of products are they typically? Duct systems, stacks, tanks, scrubbers, flumes, hoods, dampers, manholes, troughs, paint covers, stack liners, baffles, weirs, trenches, ladders, platforms, etc. And I'm going to go through and explain these photos, and I think that will help tell the story. The upper left photo and the one below it are from a project that we did at the Calumet wastewater plant on the south side of Chicago. There are 8 grit flumes used in grit removal, and they're about 200 feet long. They had to be abrasion resistant, and they had to be perfectly level on top and sloped from 18 inches on the shallow end to 36 on the deep end. All of the drains, overflows, etc. had to fall within the very tight tolerance for width. If you look at the lower photo, you'll see the large traveling bridge that moves along the side of the trough, and everything had to clear. On the upper right, you're looking at a typical wastewater plant. That's a 48-inch diameter duct that comes from across the top of the screening building, goes down underground over to a biofilter. On the lower right, you're looking at some typical butterfly dampers. We make many types of dampers. Here we're looking at a stack liner on the left-hand side. That's a 6-foot diameter stack liner. It's one section of a 200-foot tall stack. And here we had some old 1950s concrete and brick stacks that they had to modify because they went to burning high sulfur coal and put in a sulfur scrubber. And when they did that, the old brick and concrete couldn't take the sulfur condensate that would occur in the stack. So we built these liners that would drop in, and the lower section had a base that anchored, and then the next sections had a big funnel with an 8-inch socket. So the sections dropped in place, and then the very last section on top only went halfway into the socket, and that flange that you see at the top of it sat on the concrete. This allowed for expansion and contraction, and with the system the way it was, it required no internal fiberglass joints. That stack, the first one, was installed in a 4-hour period. So we were quite amazed at that. In the middle we have a typical scrubber. That happens to be a Venturi scrubber with a spin chamber on the side of it. It's a good example of our fabrication capabilities. On the upper right, we have a large hood, and fiberglass lends itself to this type of a structure. Very strong, lightweight. I think that hood was 12 foot by 8 foot. And there are several of them. They're covering gravity belt filters in a wastewater plant. And we've done quite a few of those projects. And above it, you see the typical odor control duct in a wastewater plant. Next, we're looking at a 14-foot diameter electrostatic precipitator vessel that we built for Southern Environmental Company, and it's located at Climax Molybdenum, a molybdenum plant. And this is essentially an acid scrubber. If you look at it, you'll see there's a lot of internal fabrication. Everything had to be just right. The lower photo shows, on the left, shows them lifting the upper section to put up on top at the job site. Next, we're looking at the Des Moines wastewater plant, and this one is very typical. The current method for treating odors around the wastewater plants is to use a biofilter. It's the most economical and green, earth-friendly way to do it. And the biofilters are large beds of bark or compost that they bring all of the fumes through, and they inoculate the bark with a sulfur-loving bacteria. And when the air flows through the beds, comes up under the bottom and flows through the bark beds, the bacteria eat the odors, and it's pretty efficient. But the problem is they have to have large volumes of air to do it. So they have to take all of the odor from around the plant, all the different buildings, and bring it into one location. That ductwork is 6-foot diameter, and you see it running about a 90-foot length in that bridge. It's a good example of some of the things that we have to go through. There's an expansion joint every 20 feet in that run. And the reason for that is the bridge designer designed the bridge, and our consultant did the calculations for the duct, and the duct turned out stiffer and stronger than the bridge. So it was decided that one had to give, so the bridge was allowed to support our duct only by having flex connectors every 20 feet. On the upper left, you're looking at a stack with an integral curb cover. This is something we like to do instead of going with the conventional curb cover, which involves sheet metal and tar and so on. This is corrosion resistant. It's structural. It can support the stack and the fan above, if there's a fan above it. Something we do often. On the lower left, we have a building, a panel type building. It has a foam core in it for insulation, a white interior to help light up the interior of the building when it's finished. It is for a bar screen at a pump station for wastewater. And the bar screen was located at the pump station, created quite a bit of odor, and it's kind of a dirty operation. So we built this building to cover it, and it worked out very well. Turned out only one light bulb lit the entire room because of the white walls. The upper right, we have some 20-foot span covers over wastewater tanks, barrel type covers that bolt together. We've done several projects like this. It's for odor control, and it also controls the foam that can build up in the wastewater tanks. That also has a core material, and it is a balsa core for stiffness to keep them light and stiff. The lower photo is a box scrubber. This is a typical cross-flow chemical scrubber. The air comes in one side, goes through a wetted bed of packing, and goes out the other side.
We have a question from the audience. The question is, what makes the composite UV resistant? Is there a warranty for UV protection?
Yes. You see the white color or the blue color on the domes? That's a gel coat. And the gel coat is a polyester resin with UV inhibitors and, of course, color pigments. And it's made to protect the laminate from UV.
We have one more question. The question is, as far as the design goes on a lot of these custom jobs, who was in charge of laying out the design for this?
We very often start with the design parameters and go from there. So we can do that. Next, we're looking at a large upper plenum for a fluid bed dryer. We built this for a GEA corporation. And what it is, it's fiberglass laminate with a balsa core again. The core does two things in this case. It gives structure to that large piece of equipment, and it also insulates. What they're doing is they're drying CPVC powder, and the powder is blown through this as it dries. And the problem with CPVC powder is you can get hydrochloric acid condensate in there. So there's a real corrosion problem. It operates at about 180 degrees, and the condensate is very, very corrosive. And we also have a problem with dust collecting in there, and so they have to occasionally beat on the sides, and fiberglass is a very good example. The first one that we replaced was made with titanium and a lot of framing and a lot of insulation. So this has been a very good product for them. We have manufactured 3 of these to date. At the upper right picture, you're looking at the fluid bed dryer in their facility mounted on the titanium hoppers that you see on the bottom. And just to give you an idea of size, that unit is 21 feet long and 11 foot wide, and I think 13 foot tall. So it's quite large. Let's go on to the next one. Here you're looking at another unusual project. This is the city of Kansas City. And they had first designed these wheels, we call them water wheels. And what they do is, if you look down in the lower right, you'll see some big wooden paddles. These paddles mix the flocculant into the water coming into the plant. The flocculant is mixed with the water to drop out all the particulate before the water goes to the clarifiers. It's a common practice in water plants. The paddles used to be driven with chains and motors, and that's pretty common in a lot of the plants. What we did here, the city had devised a wooden water wheel, and they blow air into the buckets that you see, and as the air makes the bucket rise, it generates torque, and they can spin 16 of these mixing paddles with one air wheel. So the plant now has, I think, 38 of these wheels. They're 13-foot diameter, and they operate with 2 air pumps.
We had a question come in, Terry. How long have these FRP wheels in Kansas City, how long have they been in use?
The first ones were put in 15 years ago, possibly, through the company that preceded Monoxivent. The last ones were put in maybe 2 years ago. Here we're looking at a typical fiberglass tank, and we've built many tanks to fit in given situations. This one is part of a energy recovery system, and it is a treated water, which can be very aggressive. But it had to fit into a given building along with ladders, platforms, and other equipment. That's a typical fiberglass tank. And there we can go up to, again, 14-foot diameter. The lower left is an unusual piece, and this one you might consider the canary in the mine. What it is, it's the liner for a scrubber quencher at the head of an acid plant. We have 450-degree hot fumes coming off of some roasters, and there's a big spray and there's an overflow that coats the entire interior of this piece that quenches it down to 180 degrees right there. And through the years, that particular part had gotten damaged every year, and every year it's shut down, we have to repair it. So we started making these liners for them, and every year they replaced the liner. That happens to be the big culprit there is sulfuric acid that's reaching its dew point due to the moisture and the temperature change. And what we've made that with is a high temperature vinyl ester resin. It has a heated distortion temperature of 470 degrees. And it's also filled with carbon. It has a carbon veil, and it has carbon graphite powder throughout it. So that's an unusual piece. The upper right-hand corner, we have some typical flat covers. And these are at the Cedar Rapids, Iowa wastewater plant. These have been in service about 5 years. They have another type of core. They have called a Nitacore. It's a polypropylene honeycomb, and it covers all of the flat panels and makes it so that a man can walk on it, takes the 45-pound snow load, etc. Yet they stay lightweight and can be lifted off. Down below, we have two 40-foot diameter fiberglass domes on some wastewater tanks. They're unusual because they have a carbon veil that helps ground to prevent any static buildup. And it's extremely corrosive. Those are ribbed sections, and I think there are 10 segments to each dome. They were assembled on the ground and lifted in one piece. Now here we have an example of an architectural project. And what we're looking at here are fiberglass panels on the top section, a stainless steel structure under it, and the fancy filigree that you see on the long straight canopy is cast aluminum. And then it's all painted or gel coated to match the color required. The building is the classic old Rock Island clock tower building. It's the home of the Rock Island Corps of Engineers. It is the oldest building in the Rock Island Arsenal, built in the 1860s. These are called stone fall protection canopies. And the requirement was they had to be able to take a 9-pound stone falling 50 feet. And the reason for that is these are the main entrances where people come in and out to go to work every day. So it was an unusual project, and it combined our home company Crawford's abilities to make stainless steel along with our fiberglass capabilities, and Crawford also installed it.
I got a question on this. Another warranty question, Terry. So what would the warranty be on a product like this?
Like the canopies? I think we have a 5-year warranty. Without going back to the paperwork, typically the fiberglass will last, 20, 30 years without any problems. So I would expect these to be there a very long time. We've got
one more question here. Is there a product that you add to the FRP to help prevent from producing static in a Class 1 environment?
Yes. Again, the typical ASTM corrosion laminate calls for a veil on the interior that holds 90% resin, and the next layers are chop strand mat that holds 70% resin. That interior layer is a corrosion barrier, and we can fill that with the graphite powder. We can use a carbon veil, which is conductive, and that can be grounded, and that is a typical application for grounding duct systems. What we're looking at here are the industry standards. The corrosion industry really got its start in the 50s. Some of the fiberglass tanks that were built back then are still in service from the 1950s. The ASTM standards all arose from an old standard called PS 1569, which some of you may have heard of. The ASTM standards cover pipe, tanks, duct, and your ASTM C582 is the critical one. That's the last one on the list there from the bottom. And that one is the typical corrosion laminate. And that's I just described a corrosion barrier, veil, mat, and then the structural. That all comes from C582. The one that drives duct is up the list there, D3982. That is the practice for how to build duct systems, dimension-wise and whatever. The tank, there's two tank standards. The top one, 3299 for filament wound tanks and 4097 for hand laid up tanks. So we're very much governed by these standards. And of course the SMACMA standard for fiberglass ductwork is another critical standard.
Okay, this is going to conclude our presentation for today. I'd like to thank everyone for their time. We certainly appreciate it. We do want to mention we have a new website, fiberglass-duct.com. That website has our online catalog, case studies, all the guidelines, a lot of this information that was presented today. Also, we have a new printed catalog that's available by contacting our office, asking for Paula Pratt. She'll certainly help you with catalogs. We have brochures for this product and Underduct as well. So please don't hesitate to call us with any questions or comments or any upcoming projects. And we'd like to remind everyone next month our webinar will be on the source capture side, and we'll be sending out notification on that. So please keep an eye out for that. And once again, the webinars are saved on our YouTube channel, and that can be accessed monoxivent.com. Click resources in the webinar tab. So once again, the presentations will be saved on the website. That was a question we had. So go to monoxivent.com, click resources in the webinar tab. So thanks again, everyone, and we look forward to having you join us next month.